is we're using our dimensional analysis again. I know that 342.3 grams per mole is the molar mass of sugar, which is what we're going to use for as that term. So all I did here was, again, dimensional analysis like we did earlier. I wanted to get rid of mole, so I put it on the wrong side. So if I want to get rid of mole, I need mole on the bottom. So I know that 342.3 grams per mole. Cancel them out. And I get my amount of grams that I need for sugar. And so that's how I knew exactly how much sugar I needed in order to have 1 mole. So really this is just dimensional analysis like we're kind of using like we did in the last chapter. So the main 2 things that we're working with is our gram per mole conversions, which you get from the periodic table, right? Because you can just look at the periodic table, you look at your atomic mass, and then you know 1. And then our Avogadro's number conversions, which is our particles per mole, so we can convert from grams to mole here or backwards, or moles to gram, and then we can use this to convert from our particles to moles or moles back to particles. Does that make sense? So these are really the only 2 conversion factors we're working with here, as we're like kind of talking about going between particles to grams here. So that's essentially what you needed to do in order to solve the problem with the molar mass conversion question that I showed online. So I know the other thing that was confusing with people is that we thought that a mole was representative of a molecule, but mole is completely different from molecules. With molecule, we're talking about the particle, right? So like, this would still be particles per mole if we were just talking about an atom. It's just that the particles are atoms. Does that make sense? Again, same thing we're talking about the dozen. Like, if we had a dozen atoms, it would still be 12 atoms compared to like a dozen molecules. It's still 12 molecules, but I'm just saying that it's a dozen because it's just like a way to kind of keep track and group those numbers together. Does that make sense? Cool. It's kind of like how, I think they mentioned in the notes, but the mole is based on the Latin term for pile, right? So if you think of a dozen that's like grouping together, a mole is grouping together, except it's just way more because it's just a pile of particles, if you want to think about it that way. So, the last thing I should touch on here is, I'm just going to erase this real quick, because this is a lot. So I said molar mass a lot, and so what I mean by that is essentially just that conversion grams per mole. But we know how to get the molar mass of like 1 element, right? So, but what about 2 elements? Let's say I've got salt here, NaCl. So if I wanted to get the molar mass of this, what would I need to do? What steps do you think I should take?
You definitely get isolated one of them. You got to isolate one of them, just like Na or chlorine.
Kind of. You're kind of on the right track here, but like what you're trying to say is, I guess, you want to get the masses or the atomic mass for each, right? Something like that. So, what's the atomic mass for sodium, y'all? Give me a quick look.
22.98.
22.98, right? And what about salt? Or not salt, chlorine.
35.45.
So now if we wanted the molar mass of the whole thing here, this whole salt, what do we need to do with these 2 numbers? Add them together. Yeah, exactly. You add them together, and if you might want to do the quick mass for me on that, they have like a calculator up on 38.43? 58. Yeah, I should have done the mental math for that. But yeah, so this is 58.43 grams per mole. And that's your molar mass. And that's it. That's how you find the molar mass of any kind of molecule. This in particular is an ionic compound, and I think in the notes it mentions 3 different types of formula masses, like at the end of the notes, where it's like molar masses are split up into 3 different types. So those are really just semantics. We use molar mass for everything. Those are just kind of the semantics aside, because it's like, if we're talking about atomic mass, we're talking about 1 atom. If we're talking about molecular mass, we're talking about a molecule. If we're talking about formula mass, usually talking about an ion. But again, that all kind of comes over this molecular mass, or molar mass term. Does that make sense? Like those are just kind of splitting those up. But molar mass is really what we kind of use for everything. So that's essentially how you do that. So now you know where I got those numbers from, especially with sugar. Because sugar is the same thing, except there's a whole lot. So you just have to make sure you keep track of, there's like 12 carbons, there's 12, exactly, it's like, can't remember exactly off the top of my head, but.
C12, H22,
Yes.
L11. Go ahead and write it. Launch it.
Yeah. So,
C12, H22, L11.
so again, for this one, how I found this is essentially the same process, except there's just a whole lot more. So, carbon, what's our atomic mass for carbon? 12.01, 12. Usually, I think people round it off to 2 places there, generally, so 12.01 is good there. So, how many carbons do we have?
12.
So, what should we do with this number? Times by 12, yeah. All right. Hydrogen. I'll put parentheses around it, yeah. It's about 1. Yeah, you could say it is about 1. It's enough, close enough to 1 where you can say that. So 1.01 on there? Yeah. So use 1.01 here. And then there, how many hydrogens? 22. So again, we multiply by 22. And then oxygen, what about? 16.
15.99.
16, so 16 point what? 0. There you go. And then again, we're multiplying this by what? Again. So yeah, when you do that, you add it all together, you get your molar mass of 342.3 grams per mole. Right? Does that make sense how this math works out? Yep? We're good? Cool. So now we're going to do some actual practice on this today. Because just seeing it is all good, and we were kind of walking through it together, but I want to get y'all some practice on this. So first, we'll go over that problem that I showed online for y'all, or that I gave y'all the molar mass question, and just kind of walk through it. Yeah. Okay, so whenever it loads up, you scroll down to the top here. So yeah, this is the molar mass conversion question that I gave you online. I'll walk through this one, and then I'm going to give you all a worksheet, and we can kind of go through that one together, because it'll be a little difficult to get through these. So if I had 2 moles of sugar, how many grams would I have? So let's start off with this question. So what do you think we should do first in order to find grams? So we're trying to find grams of sugar from 2 moles of sugar. What do you think we should start off with?
You have to cancel out the moles somehow.
You have to cancel out the moles somehow, Sam. So how do we set this up then? What would we write here?
You put.
If we're doing it like dimensional analysis like we were doing earlier, right? We're starting off with, what are we starting off with here? So we're starting off with specifically what?
2 moles.
2 moles, right? So 2 moles of P. If you're right, that's the molecular mass. We're going to get that. But we're starting off with 2 moles of sugar. So again, we're going to write this as a formula. Okay? So we're going to set this up just like a dimensional analysis problem. What do we need to do next to this thing? Jackson, you were kind of on it earlier. What do you think? So you said put 3.4 or 2.3 grams on the top, and then 1 mole at the bottom? Yeah. All right? So then these units, which units cancel out here? Moles. So it's just like we were doing earlier. What do we do from here?
2 times 42.3.
Yeah, 3 times, or 2 times 342.3 grams. And then so what do we get as our final answer? 684.6 grams. Yeah. Good. All right, so now let's talk about if we're trying to get the number of molecules here. Again, so where are we starting from?
Moles.
Moles. So yeah, we'll start with 2 moles again. So 2 moles. All right. So now what do we need to do in order to get to molecules?
Put 1 mole on the bottom and 6.02 times 10 to the 23rd on the top.
Yeah, that sounds about right. So you said put 6.02 times 10 to the 23rd. What?
For 1 mole.
Over 1 mole? What's the unit on the top here? I heard molecules from Ella. Oh no, from Caroline. Gotcha. I couldn't tell because of the mask. So we have molecules on top here, right? Because we were trying to find molecules in the first place, right? So we used Avogadro's number as that conversion rate. So remember to just try to keep your units in line as much as you can. Yeah, Clay?
Okay, so there's that number
Yes.
in every molecule, or in every mole.
Yeah, every mole has 6.02 times 10 to the 23rd particles. So it could be atoms, or it could be like molecules, or it could be like donuts, or you know. So the mole is just there as a counting. Like I was saying with a dozen, right? So if I had 1 dozen of something, so like let's say I had 1 dozen atoms, how many atoms do I have? So yeah, it's the same conversion rate. It's the same style of conversion rather. So it's like if I have 1 mole of something, how many atoms do I have?
6 point.
That number? What number is that?
The
Avogadro's? Close, yes.
Avocados,
So, Harrison,
put your
you got it?
guacamole.
How do you know whether it's a molecule or an atom or not? How do you know which particle it is?
What is this? A molecule or an atom?
Um,
It depends on what you're working with, right?
Yeah.
So we were working with a molecule, so we're doing molecules. If that was just an atom of carbon, we would be working with what? Atoms, exactly. So, again, that's why I say, when we say particle, that's what I meant by particle. Because it could be literally whatever. It just depends on what you're working with, right? If you have a dozen of donuts, you're working with 12 donuts. If you have a dozen of marbles, you're working with 12 marbles. In the same sense, if I have 1 mole of marbles, I'm working with 6.02 times 10 to the 23rd marbles. Does that make sense?
So if you're given an element, it'll be atoms. If you're given a covalent substance made up of molecules, then it's molecules. If it's an ionic substance, then we use formula units instead of molecules, because technically they don't form molecules. But you calculate everything the exact same way.
So that thing is sugar, I think that's 1 mole, so that's
This
like,
is 1 mole of sugar.
that's that many molecules.
Yeah, so 2 times this, right? Which is,
Right.
did y'all end up getting this?
I just put 2
1.2.
times.
You just put 2. Keith, you were saying that? What were you saying?
1.204 times 10 to the 23rd.
Not the 23rd.
24.
Yeah, 24. I heard it. Everybody else kind of chipped in, so good job, y'all. So again, just making sure for sig figs, will we write this as 1.204, or what would we write this as? 1.20, yeah. 1.20 times 10 to the 24th molecules. So yeah, you're right in the sense that this number right here is how many molecules are in here. Here. So honestly, I wouldn't have been able to fit in 2, right? Because we're already on half. But if I did fit in 2 moles of sugar, we would have had this many molecules just in this vial alone. So what does that tell us about an atom or a molecule?
Very small.
They're super tiny. Yeah, exactly. So yeah, again, an even better example here is like this sulfur these are just atoms of sulfur. This is just 1 mole of sulfur. So this is still 6.02 times 10 to the 23rd molecules. It's just that sulfur is a little bit bigger, so it ends up filling a little bit more. Like this example, again, going back to a dozen. You could have 12 donuts, or you could have 12 big donuts. They're going to be different, but they're still both a dozen donuts. Does that make sense? Yeah.
So a molecule of sugar
Yes.
is bigger than an atom, or like a thing of sulfur, right?
Yeah, right? So
Okay.
let's look at that. So we know that sulfur is just 1 atom, right? Let's see, where? Oh, I think it's over there. Our super small molecule. So you saw this in the middle video, but let me find it real quick. So I have that here. There it is. So one molecule, so we have like an atom of sulfur, right? So if we're comparing that to this is what we're working with sucrose. Notice how there's a whole bunch of it, and there's a whole bunch of atoms kind of covalently bonded together, and you get this huge molecule, right? So we're still working with the same number, the 6.02 times 10 to the 23rd, but like I was saying, like it's like kind of the difference between donut and big donut. You still got a dozen, but one's going to be way bigger than the other. In the same sense, you've got this here, because this molecule of sugar is way bigger than these atoms of sulfur here, but these are still both 1 mole. Does that make any sense?
Yeah,
Gotcha. Any other questions on that? No? Pretty comfortable-ish? Don't worry, we'll get more comfortable with these calculations right now.
Hold on, let me just ask one question on that to kind of clarify. If I want to make 1 mole of sucrose, the sugar, what do I need to get? What do my raw ingredients need to be?
Atoms.
How many?
that
That many.
If I want to make 1 molecule, I got to go get 12 carbon atoms. I got to grab 22 hydrogen atoms. I've got to grab 11 oxygen atoms, put them all together kind of like this to make 1 molecule. Now I want to make a dozen of these. How many carbon atoms do I have to get? 144, which is 12 dozen, right? What do I have to get for, how many hydrogens do I have to get? 22 dozen, right? And if I want to get 11 oxygen, to make a dozen of these, I got to get 11 dozen oxygens, right?
So sugar's not man-made, like people don't get.
No, you use a sugar cane.
No, it's not.
Okay? Now we can make it, but it's way more expensive. It's easier just to grow it. Okay? So if I want to make a mole of this, how many carbon atoms do I have to get? What'd you say, Caroline? Just 1 mole? 12 moles, right? If I want to make a mole of the big molecule, I got to get 12 moles of carbon. How much hydrogen I have to get? 22 moles. And 11 moles of oxygen. Now we put them all together so all of those individual pieces grow into this one big piece. So we only have 6.02 times 10 to the 23rd actual molecules, but we have a whole bunch of individual atoms making that up. You following that? Okay, so this tells us how many individual atoms are in a molecule, but it also tells us how many moles of atoms are in 1 mole of the molecule.
So that's one molecule, so then you need like that times the moles?
Yeah.
Oh,
Okay, so 1 molecule is this many. A mole of this is going to be 6.02 times 10 to the 23rd of these. You can even think of it, you know, you have the water molecule. I have 3 particles right now, right? So if I'm going to put them together, H2O, now how many particles do I have? Only 1. It's much bigger, so it's going to weigh more. It's going to weigh the combination of 2 hydrogens and 1 oxygen, but I only have 1 molecule. So 3 pieces come together to make 1. 12, 22, and 11 pieces come together to make 1 huge one. All right.
Okay.
That's just a super important concept, making sure.
All right. So I'm going to go ahead and pass these out real quick. So this is just a full conversion worksheet here, just so we can kind of get comfortable with converting between these, because you do this a lot in chemistry.
A lot.
A lot. So we're going to do the first one kind of together, again, like we did with that problem. Then for the next few, I'll have y'all pair up and just kind of like try to see if y'all can work it together and just talk about how y'all are working through it, and then reconvene after that. And then if we have enough time today, I do want to go through and at least go through and kind of watch through one or two of the videos and just kind of give you some feedback on whoever I can for that. So let's start off with this first one.
Move it down just there.
Yeah, that would be important. So we've got this one right here. How many moles of lead, PV, are in 1.50 times 10 to the 12 atoms of lead? So first off, where do we want to get to? Yeah, we want to get to moles, right? So what do we have at our disposal in order to get to moles? What are we given? Atoms, right? This specifically the 1.50 times 10 to the 12, right? So what's our conversion to get to from atoms to moles? 6.02 times 10 to the 23rd, what? Atoms per mole. Yeah, atoms per mole, exactly, right? So again, we're going to set this up here. So we have our 1.50 times 10 to the 12 atoms of lead. Again, lead is Pb. We set up our little table here. And so when we use this conversion to atoms and molecules, where does the, how do we set this up? Where do we need to put the numbers at?
You put the Avogadro's on the bottom and put atoms or put one more on the top.
So Avogadro's number on the bottom, and then put the rest of the bottom side of it, the moles on top, right? Is that what you're saying? I think you said that too, Ella, but Sam was just a little more detailed. You said just bottom, but I think y'all get it. So 6.02 times 10 to the 23rd atoms here over 1 mole. So what cancels out here? Atoms, right? Boom, boom, gone. And make sure atoms of Pb, because again, we're working with atoms of Pb of lead, so we're making sure to cancel it out that way. And so all we got to do now is just do the math. So if y'all want to do the math, go for it, and then tell me what y'all end up getting for this. Okay, you might want your calculators for this. We're going to do a good bit of math here. Some quick math, exactly. Quick maths.
I did it in my head.
Yeah, I guess I could.
Can you throw those in your head?
I can do that in my head.
How do you divide scientific notation?
So how do you divide it?
You know how to put it in your calculator?
I don't know.
Just use a parenthesis.
I know how to put my calculator.
I mean,
We can type.
you're just gonna go, I mean, 1.5 divided by 6.02, that's basically 0.25. That's a fourth. Then you just subtract your exponents. 12 minus 23 is gonna be negative 11. 0.25 times 10 to the minus 11th is going to be 2.5 times 10 to the minus 12. Mental math, you guys are capable of doing that in your head. Yes, you just gotta put that calculator down.
Just because you're capable doesn't mean you need to do it.
No, but everybody does need to make sure you can do it on your calculator.
Yeah.
I can do that.
Do y'all need
Yeah.
to review that and how
I
I
can do it
would
on my
input this on my calculator? Or do y'all understand?
Okay, so you just do like the 1.5 times 10 to the 12 in parentheses divided by that one?
Yeah, so
I would use
basically-
a parenthesis in the bottom too.
Yeah, I would use parentheses on the bottom as well, because otherwise, what it'll do is it'll PEMDAS you, and it'll divide by 6.02, and then multiply the whole thing by 10 to the
Yeah,
23rd.
especially those
So-
calculators that you have, you really have to use parentheses. If
Yeah,
you
so
have,
just, yeah, making sure you just parentheses
yeah,
every.
they all have the same one.
Yeah.
Use parentheses. Jackson, let me see yours. Turn it around. Yeah, his is easier.
So what did we end up getting for this one?
2.49 times 10 to the negative 12.
10 to the negative 12. Yep, and that's about in line with Mr. Hubb's mental math there. So it looks like everything lines up and makes sense. Does that make sense for everybody?
Wait, it's negative mole?
So it's negative moles, because again, we're talking about a group of moles, because remember, how big is a mole?
Like way bigger than the atom.
So like how many particles are in a mole?
6.2 times 10 to the 23rd.
There you go, y'all got it. So, I mean, we can have a 10 to the negative 12th, right? Because we're really only chipping off like 12 places of 10 off of that giant number, right? So we still have this many atoms in that one mole. It's just we have like, because of that, it's not as big as what a mole wouldn't be. It's kind of like having like a third of a dozen, right? How much is a third of a dozen? 4, right? It's less than a dozen, so we can't really use a whole number for that, and it's still below a dozen, but it's not necessarily 0. And it's not necessarily, like, you can only go out so much, yes.
Just remember, a negative exponent doesn't mean a negative number, it just means
Yeah.
it's decimals.
Mhm. Does that make sense for everybody? Yep. Alright, so now I'm going to let y'all do the next few problems on your own here. So I want you to pair up with somebody and talk about these and kind of calculate them. We're going to try to do 2, 3, and 4 together. So just talk to your neighbor, like try to get everything set up like you think you should set it up for these problems, and then I'll give y'all, what time is it?
20, 30, you have 18 minutes.
18 minutes? Ooh. I'll give y'all till 1:40, and we'll talk about them. I don't think we'll get to showing any of the videos today, but I'll go through and grade them tomorrow and give y'all some feedback on those. So. Yeah, 2, 3, and 4. Yeah. No questions are dumb.
So we're multiplying. We're trying to find.
Moles count.
So here, which number?
Oh, so if you're on table, it's the one in the top.
It's the red, so
Yeah.
it's 40.078.
So how do the moles cancel out?
Yeah, is it?
Moles per single gram, right?
So what's your unit for atomic mass? Is it moles per gram or is it grams per mole? Yeah, so what should you do with that 40.07? Yeah, there you go. Yeah, it takes a little bit, trust me. It's no dumb questions, you're all going to use this, all right? So what's the units of this 40.07?
It's the.
Gram per mole, right? So if we multiply by this, are we canceling out the grams and getting moles?
How many?
Wait, don't you have to get to atoms?
Will grams be on the bottom here? Because remember, when we're talking about grams per mole, it's like you have grams, moles, right?
Do we have to put this in the sign?
When I say per, I mean like that's what it means by per. So usually you always have like one unit on top and one unit on the bottom when you're saying per. So yeah, if you write it on bottom, now your grams are on the bottom.
Wait, so what I'm thinking like,
This
Right.
scientific notation.
So the ratio, so when you say atomic mass, it's one AMU is 1 gram per mole. So it's like, it's whatever that number is on your periodic table, it's written as 40.4078 grams over 1 mole.
Now, this
This
one
is the
just
ratio
won't go
is
up.
the number of grams per
Okay.
1 mole of that substance.
So,
So if you flip that around, because you gotta cancel grams,
yeah,
right?
molar mass is
If you
always.
flip that around, your grams are down on the bottom and your moles
Okay, it's always the
are top.
mass of one.
So that's why we end up flipping it around, that's why you divide in order to get the moles.
You can if you want to, you don't have to.
Does that make sense?
Oh, okay.
It is a little hard to get used to, and like I said, this is why I want to just get a couple practice problems under your belt, because
Well,
the
but
more you do it,
again,
the
we
more
don't
it's just
want
kind
moles.
of tongue click.
If you did
And
this,
yeah,
you're
make
gonna
sure
go
we're
all
talking
the way
about
to
the other
atoms.
classmates too, because we,
Okay.
we're all figuring
The
this
question
out.
was, if Joe, the grams to moles, you only have to use this. So
Yeah, yeah.
1 mole of
I assume
this,
that's a gram,
and
not
that's
a
it.
cent.
This, if you can use this one, you gotta go all the way to atoms.
Wait, what'd you get, like 0?
So if you don't need this top one,
oh, so it's,
yeah, you just put 1 mole on the top here. So 1 mole is.
Oh, I got that too, but I thought that was
So
Once
this
you
dimensional
get
analysis is all the
40.07,
time.
that's your atomic mass. That's the mass of 1 mole, so grams cancel, leaving
So when you get
moles
to
of
the
calcium. That's how many moles you have. So 1 mole is 40, so you only have 3.52, so you only have a real fraction of a mole.
Yeah, I guess that's something important, but you can have a fraction of a mole, just like that last one we just did.
Why do they call them moles?
Are they called mole? So that's from the Latin of heap or pile. They use that as the word. So essentially, if you think about a mole, it's just one giant heap of particles. Now, probably wouldn't be as big as a heap that you'd see in like real life. Nobody's going to stack up 6.02 times 10 to the 23rd like donuts in real life. But it is kind of where it came from. Yeah.
Okay, so for this. we
And
have
the abbreviation really helps, MOL,
And that's
that's how you abbreviate it.
Right.
Just
So it's
really helps.
so down that.
Okay. We gotta do, put this answer in two zeros because of that, right?
Yeah. Mhm.
So that would be,
Remember scientific notation, right?
the zeros are, oh, we have to put it in scientific.
Well, it's easier to keep it in track, especially when it's that low.
One, two,
Kingfish copper.
29.
9.53. I got it, I said.
So does that mean that?
eight,
No? Did you not do it?
Your secrets are only, remember, there's only two secrets. Yeah. Mhm.
Oh, you do?
Exactly.
Oh.
Yeah, and everything else is right. Okay, you set it up right, you got the whole, yeah, perfect.
So you do that,
Yes.
Caroline, you did this number? Divided by
They
the
set up
total.
Yeah, so what's the gap there?
Oh, okay.
Yeah, listen, better than me. That's right, you're trying to, you're trying to get moles, right, so you can get rid of the grams. Yep,
Is that?
that sounds disappointing.
is that right there?
Like, I thought it was like.
So when you don't need the mole down, though, because basically, yeah, it's dividing, you're already doing it in grams per mole, so it's like one side's always gonna have the gram, the other side's always gonna have the mole. So, yeah, basically by dividing it, you're basically getting rid of the grams, but you're leaving the mole because the mole is on the bottom, and when you divide it, those units flip.
Another big question.
Another stupid question?
So this would be in two zeros. So when you transfer that into two zeros, it'd be this. That's two zeros.
Yep, it is. So they use to set trailing zeros and count if there's a decimal.
Okay.
That,
That doesn't count, it's no decimal.
that's one. But if I were to do
Wait, so
this,
we,
that's three.
Yep.
And
It's
then
a
what if I were to do
Is
this?
it three?
Is that four? Is that?
Yeah, so basically zeros that are placed with decimal points, they're usually there to indicate that like, you can only go out so far on your measurement, but there's still like some random nonsense past that decimal point. Whereas like, if there's no decimal point, it's like saying, like I said, a couple months ago, where it's like, yo, I got 1,000 likes on Instagram. Like I didn't really get 1,000 likes exactly, but I got somewhere around that. So I use that as kind of a placeholder that must be helping.
Actually, my dad got an Instagram account, so now I get two.
Let's see here.
My dad got an Instagram account, so now I get two likes. Oh, yeah, I get
No,
two.
no, so
So
let's think about, let's think about the past. We're getting 2.4 times the third grade. We're trying to get to moles. So, what is our Avogadro number? Is that
No,
now?
I think the thing is that too.
because they don't have to go.
Avogadro number?
Like you should
Yeah,
just-
so Avogadro number is part of the You're asking the wrong. It's like the same story. It's not that. Also, it's the same time. So, what other?
I'm not doing all of them wrong.
That's the mole
Get to
of
grams of
copper.
this
You
particular.
can't find the moles either.
What?
We just did it in the previous one.
Wait, so if it's grams, you just use the atomic mass every
Yeah, atomic mass, right? 'Cause our atomic mass is measured AMUs, but one AMU is
I did not know how to start
So,
another math
we can use our
class.
common mass to calculate, to get into grams, right? So,
Caroline, have you
your
used
setup would
this?
be right to canceling out grams per mole here,
Yeah.
but
How do
this
you
number
think you
just
can
goes by
focus
the atomic mass.
that last question.
What's the number for?
Oh, I hate infinitely many functions on one of the lines.
Yes, okay, that's what I had 2 minutes left.
Yeah, and I tested eliminating another variable too, because I had time to like.
So,
Yeah.
I literally had 2 minutes left on this.
No, next thing you know, I'm gonna start doing sig figs and like.
Or six.
Absolutely not.
That's four.
Who's
Sig
math?
figs are reserved for this class. I know.
So normally this one would still be one without the decimal point because
Is it hard?
but because of decimal point, this one is
Yeah.
balancing.
Man, I'm just so scared
The last
for my
question is
joints
only
because
they're
they're tests.
scrapped in.
That's what it was on
If
the
they're trapped, they're
regular
always.
sheet.
You
So like 100, that's one.
Wait,
Yeah,
what?
is it explain your answer
So how
one?
many is this?
Is it explain your answer one?
Gotcha.
Yeah. Also, you need to make sure you round right. You got 0.010.5. So what would that round up to? Wait, the number six is not
I
right.
got your-
That's what
I
I'm
think
doing.
it was one of them stuff, but
I wish I didn't say
after
that.
time.
I kind of felt bad. I didn't realize the group that was.
Wednesday, if you're so confused on like six
What
days.
Because I thought it was just like me, and I was like, I'm gonna do it.
Mr. Hans, if we're gonna host a Google Meet.
Then I saw all y'all
for
being
kids,
there.
what time would we want to do that on Wednesday?
Well, I have to give the work keys test tomorrow,
Okay.
and so I will be unavailable until 12:30 or 1.
So we get host at like one maybe?
They don't let me eat,
I mean,
drink,
I can do,
I'm barely able to breathe.
I can do the six things that I have the,
On every level, but
I
I didn't.
got at least,
Um,
oh wow.
you
I'm
can
so
ask,
wait,
but
I'm
if you wanna
hoping for
try
a
to
seven.
leave, I mean, I'm just in jail tomorrow, watching
I'm hoping for at least
can't
a
read,
seven.
I can't breathe,
Good for
I
me.
can't eat, I can't
do you
drink.
need the Chromebook for that?
I can't touch anything, I have to just sit there and stare for 5 hours.
You have the same mindset
Alright,
as this
so I'm
man.
gonna try to host it at one.
It's
and-
horrible.
We were talking about it yesterday.
It's cruel and unusual punishment.
What do you got?
Wait, what are you talking about?
The
Having
word
us,
keys,
working
the word keys test.
Administer the work keys test, or the ACT, either
Yeah.
one, you, I mean, you
I
could.
guess if that's the case, then I could
Oh,
probably just.
wait,
Can you, like, find your phone?
Host it at last time.
I did the wrong.
Why not next
You
week?
can't have any electronic device in the room, period.
Because
That's
You
pretty.
can't play Among Us on your phone?
Do you have water?
I can't even play tic-tac-toe with myself.
Can you have water?
The water, I mean, I'm sure you can have
use the
water.
bathroom?
But I gotta get somebody to come in and
Yeah.
hold my hand as I go.
Just stand in front of the class and just do this the whole time. Just,
No, I sit in a chair and try and stay awake.
Yeah. So yeah, I mean, I'll host it, I'll probably do it at class time, so 12:45, and I'll get it together. So if you are confused with sig figs or need help with sig figs, I'll do that. I'll also post it online so that way everybody else can kind of see when we're doing it, and I'll make an announcement on that when
Okay, so whenever I'm rounding this for the scientific notation, and this is my answer, what is my molar?
does that mean?
Like, is that right?
So you're not exactly right. So how many sig figs are, what's your least number of sig figs when you're dividing? Two, right? So this should be how many sig figs? So, yeah, there you go.
And then I fix it.
Yeah, exactly. That's a good way to show sig figs. You can alternatively, it generally with like smaller numbers, I always suggest doing just like scientific notation, which is that, because it's just way easier.
One mole is always
You can
on top.
technically,
The molar
if you
mass
use
is
to,
always grams.
to show significant zeros, you can
Just
write,
divide
you
it
can like,
all the time.
you can put a line over that's the best way to do it.
Okay?
But if you're writing scientific things, since
So where is the atom?
but then just look at it, you gotta.
So that's what I thought.
Yeah, it's not a lot easier to work with scientific, or with scientific notation with that big numbers.
So that's.
Especially when I give the number in scientific notation, why is it?
That's the burden factor, it's always that many atoms in one mole, this many grams in one mole.
Alright,
So this is the number of atoms.
That's the number of atoms in one mole.
So,
If you have this many grams.
it is 1:40, so we have about 5 minutes to go through these. It seems like y'all went over to problem 5 too, which is good too, so it means you all are getting into it and learning how to do these conversions here. So let's briefly go over this and just to see where we are and see if we're all like on the same page on these. So how do we end up setting this one up, this moles of calcium here? 3.82 grams.
And then it's 1 mole over 40.08.
1 mole over 40.0, sorry, what was that number again?
8 grams.
0.08 grams. And so what do we end up getting for the answer?
I've got 9.53 times 10
9.53 times 10 to the negative second. Does that line up with everybody, what they got? Does that make sense? We're all on the same page. Anybody different? No?
Oh yeah, I didn't put it in scientific notation.
Oh, you just didn't put, okay, what did you get if it wasn't in scientific notation?
0.0953.
Oh, that's,
Number five.
yeah, you're raising your hand, Clay.
Can we jump to number 6 and do that one, because the other ones are basically all the same thing.
Gotcha, okay. Yeah, we can totally do that to number 6, yeah. But it seems like if y'all got this
It's
one,
all the same thing.
yeah, if y'all got one, then or this 2 here, you'll get 3 to 5.
Are we supposed to
Yeah.
finish this and turn the rest in after class?
What do you think, probably, or should we just?
But do you have anything for them tomorrow? I mean,
Tomorrow I don't really have anything for them
yeah,
tomorrow,
they can
so.
work on that tomorrow.
Yeah, y'all can finish this tomorrow, yeah.
I'm just making sure.
Yeah, it's all good, I understand. Alright, so let's work on this one. So, molar mass of sucrose. So,
That's 342.3.
342.3. Again, if I didn't already give it to you earlier, how would you end up getting this?
Find atoms that are
You
in
use
the
carbon, hydrogen, oxygen, all that.
So yeah, you get the amount of carbon, the amount of hydrogen, the amount of oxygen. You combine all the molar mass or the atomic masses with those to get your molar mass of sucrose. Yeah. So y'all see the both got it. You kind of both said the same thing, just in slightly different ways, but y'all both got the same idea. So again, this is the grams per mole. So now what we need to find. So we have our molar mass of sucrose. That was the first part of the question. Congratulations. Second part of the question: how many molecules of sucrose are in 4.6 words? 468.4 grams of sucrose. So what are we trying to get in this problem?
Molecules.
What are we given?
Gram.
So this is kind of like a 2-step problem. So we know that we got. Sorry, what did you say?
You just do like you did on 5.
So yeah, you start on 5, and what did you do on 5?
Oh, you go back.
You go backwards?
Gram.
So we have grams. We're trying to get the molecules, right?
Oh,
So first off, I guess, what do we need to get to make it easier to get the molecules?
Do we divide by 34, 342.3? Like do moles over 342.3 grams?
So you said 342.3 grams, like this?
Yeah.
Does that make sense to everybody? Does that everybody agree with this, or y'all have a different plan? No? Yeah. So yeah, that's how I would start it. But again, we're trying to get the molecules, and we have moles, right? So how do we get to molecules from moles?
The avocado nut,
Avogadros. The avocado number. No, Avogadros. I get it, but you have the right idea. Keith, I'm pretty sure you have the exact same answer. You just kind of raised your hand down there a bit. But yeah, Avogadro's number. So where are we going to put Avogadro's number in order to get to moles here? Are we putting Avogadro's number on the top or on the bottom? Top? Alright, so we'll put 6102 times 10 to the 23rd on the top. So this would be what? What are we working with?
molecules
Molecules of what?
of sucrose.
Yeah, molecules of sucrose. So I'll write it as C12H22O11, right? Oh, that's not. There you go. And then on the bottom right, we put our per mole. And that's how you solve that problem. So yeah, y'all came up with that solution pretty easily. So
Y'all are
yeah.
all talking crap to me about skipping to number 6. You know you didn't know.
Yeah, no, it seems like you all got it. So yeah, that's for Wednesday. Just fill out the rest of it. You've already got most of it done. The last 2 are on are like finding the average atomic mass, which I kind of went over more in detail from the video on Monday. But yeah, seems like I've got a good handle of this. So just finish out the rest of this for Wednesday.
I know, look, like midway. If I get like that for me, look, midway through the class, I have no clue what's going on, and then all of a sudden,
Yeah.
like,
Yeah, everything started clicking for you, Clay.
it hasn't clicked for me yet. I'm not like literally like somebody
Yeah.
literally clicked a button and it just made my brain think.
Yeah, I think the problems definitely help. Like once you get in the hang of things, you'll definitely start figuring it out. All right, y'all good, man.
That was good though. I said that was a good day.
It was a good day. I think, especially, I'm really happy that Clay started to learn. Like he really started picking up. His sig figs were actually pretty on point too. Like he understood the rules for sig figs when he was doing the problems. So I think it's just one of those things. I think he's just a really hands-on learner. He needs to just do stuff in order to figure it out. shoot.